This video is to help out anybody who might still be struggling with solving equations, especially if you weren't here when we took these notes in class. So first off, let's talk about this word inverse. Y'all learned this last year, that this means that you're using opposite operations. So like the opposite of addition is subtraction, the opposite of multiplication is division, the inverse of squaring something is to take the square root. Okay, so in algebra we're doing everything backwards, which means we're undoing equations. So you do the opposite of what you would normally do. Here's kind of the 3 simple steps you're going to follow when you're simplifying or solving an equation. First, if you can simplify that problem in any way, look at one side and the other separately, and if you can simplify it, do it. Second, you're going to move all your variables together. If you have more than one variable, you don't know which one you're solving for, so you want to move them together. And then the last step is solve the equation, which you do by isolating that variable. Okay, so let's do several examples. Some of these are exactly the same as what we did in the notes. Some are slightly different. So this problem, if I look at each side separately, there's nothing I can simplify about 4x minus 5. There's nothing we can simplify about just a 15. As far as step 2, moving all your variables, well, there's only one variable in this problem right there, so we can skip that step. We're just going straight to solving. If I'm going to isolate this x, I've got to get rid of this 4 and get rid of this 5. We get rid of the 5 first because you would normally solve a problem using PEMDAS, right? Well, in algebra, we've already said we're doing everything backwards. We're doing the opposite operation. We're also going to do PEMDAS backwards. So that's why we're going to start by clearing out any addition or subtraction in the problem. So the inverse of subtracting 5 is to add 5. Okay, the goal is get x by itself. This right here, negative 5 plus 5, will clear that value out. If you do it to one side, though, you have to do it to the other side. That's how equations work. You have to make sure that both sides of that equal sign are equal. So 15 plus 5 is 20. We've canceled out the 5 on this side, so we're just left with 4x. Now to get rid of the 4, you've got to think, what operation is happening? Well, that's like a little multiplication happening. So the inverse of multiplying by 4 would be to divide by 4. I've got to do that to both sides of the equation. 4 divided by 4 is 1x, and 20 divided by 4 is 5. The 1 we kind of talked about last week is fairly meaningless in this problem. I mean, you'll see people every once in a while divide by the 1, but 5 divided by 1 doesn't change anything. So you can just box that answer. Anytime you're trying to prove that an answer is right when you're solving an equation, you can take that 5 and plug it right back in. And so if I put a 5 right there, I know it's little, you do 4 times 5 is 20. 20 minus 5 is 15. So it totally works. Okay? Just slightly different, but kind of the same steps here. If I'm going to isolate x, it can't be simplified. There's not more than one variable. So now I'm going to go through. I'm going to clear out this plus 4 first. The inverse of adding 4 would be to subtract 4. So those cancel out. Negative 1 minus 4. We had a lot of confusion about that in class. Guys, think about a number line. If I'm on a number line and I start at negative 1, minus 4 means I'm going to the left 4 spaces. So I'm at negative 1, I'm going to go 1, 2, 3, 4. And then if you count that out, that leaves you at negative 5. So now, x over 2 equals negative 5. Well, this fraction bar means dividing by 2. So what's the opposite of dividing by 2? The inverse of that would be to multiply by 2. If you divide by 2, then multiply by 2, those actions cancel each other out. You're left with just the x. And negative 5 times 2 is negative 10. Okay? Those are the simple equations that you saw last year, a lot of. Okay? If they're in a weird order, like this next one, this is not a big deal. You just want to rearrange it so it looks a little more familiar. The first thing I like to always clean up is this equals -11. Most of us like to see that at the back. That's an easy fix. I'm just gonna take it off the front and toss it on the back. The other thing that's kind of unfamiliar about this problem is you'll kind of notice that this structure where the variable's in front, the constant is behind it. Same thing here, the variable piece is in front and the constant is behind it. Well, this one has the variable at the end and the constant in front. We can just completely rearrange that to put it in the right order. So I can put the 3x in the front and the 7 at the end equals -11. Here's what you have to be very careful about though, if you rearrange those, is this 7 is a +7, right? Everyone can see and agree that that is a +7. That means I need to have a plus in front of that 7. This minus that you were wanting to put there is actually part of the 3x, okay? So it's gonna follow the 3x up there to the front. Don't just switch them and leave a subtraction sign. It's not the same. 7 minus 9 is not the same as 9 minus 7, okay? All right, now this is very familiar. The opposite of adding 7 is to subtract 7. So I end up with -3x equals, again, think of a number line. I go to -11. I go back 7 more spaces, leaves me at -18. I have -3 times x here, so the inverse would be to divide by -3. -3 divided by 3 cancels out, and x equals a -18 divided by -3 is +6. Again, I could plug this back in right up here if I put a 6 right there. 3 times 6 is 18. 7 minus 18 is -11. All right, if you're not good with those, stop this, rewind it, and watch those 3 again, okay? But now I'm moving on and adding something. Still looking at step 1, I can't simplify that side at all. So I can skip step 1 still. Now let's move the variables together. There's more than one variable in this problem. So I've got to either move the 4x over here, or I've got to move the -7x over here, okay? You can move whichever one you want, but as a hint to you, and I would write this as a little note to yourself, move the smaller variable. Trust me, it'll make your life easier. I'll prove to you why in just a minute. So what's smaller, 4 or -7? I'm going to go with -7. So if I was just trying to move the -7 and not the -7x, if I was just trying to get rid of -7, I would divide. But I'm trying to move the entire thing, so I'm actually going to add or subtract. That's why that's written under that step. So with addition or subtraction, how do you cancel out a -7? Well, the inverse of a -7 is to add 7x, okay? You're going to do the entire 7x, that whole term. I want the x to go with it. It'll cancel out over here. The same thing though, guys. If I add 7x to one side of an equation, we have to add it to the other side of the equation. And I went ahead and lined it up with its like term. So 4x plus 7x is 11x. Minus 3 just carries straight down. Be careful when you pull this 25 down. A lot of kids have a tendency to ignore that negative, that minus that's attached to it. Don't lose that. It's part of the 25, okay? And so I'm showing really good, clear steps. This is what I want you to show when you're solving an equation. Now I'm down to can't simplify anything. I have just one variable. So here, if you started out trying to isolate this variable, well, which one are you isolating? You can't get both of them by themselves, so you've got to combine them first. All right, I'm going to add 3 to clear everything away from that x. I get 11x equals, let's see if I'm at my number line, I go negative 25 and I come up 3 spots. That would put me at negative 22. Divide both sides by 11, and it works out beautiful, almost like I pre-planned it that way to get negative 2. Okay, if you want to check it, go back up to the top, plug in a negative 2 there, plug in a negative 2 there, punch it into a calculator because you don't want to think that hard about it, and they should both equal the same amount. Okay, in this case, they're going to both end up equaling a positive 11. Okay, all right. So I'm going to do a separate video with a couple harder equations. So if you are ready to move on, go ahead and move on to the next one.